10-5. Independent events. I can find the probability of independent events.
Thank you, Hayden. Very nice job. Everyone put your iPads down because remember your eyes need to be up here. So, compound events would be like the overarching label for independent events. We're talking about more than one thing happening at a time when doing an experiment, or what's another name for an experiment? You do it over and over and over again? A trial, right? So compound events, two separate occurrences. The difference is independent events would be compound events that don't impact each other. Drawing a stick, putting it back in the bucket, and drawing a stick. My first draw had no impact on my second draw, right?
Yes.
Dependent events would be, they impact each other. So if I draw a stick, throw it in the garbage, and draw another stick, would that first draw impact the second draw?
Yes.
Yeah, because I didn't put it back. Okay, so that's a basic understanding between independent and dependent events. Now, you need to understand that there are two different formulas for these events. Independent events formula. Almost for the intelligence level of people in this classroom, which is very high, I could have almost just given you the two formulas and said go. So independent events would be, here's event A, here's event B. How many events are there? Two. Could I have more than two events, by the way?
Yes.
I could have A, B, and C. But the point is, for independent events, they don't impact each other. So all you're doing is calculating the probability of the first one, calculating the probability of the second one, and doing what?
Multiplying.
And if I have a third event, we would multiply by the third event. Call it C. If we had a fourth event, we'd multiply by the fourth event, call it D, and so on and so forth, right? Here is your examples. Number 5, I would read through them, and I would especially read through a question like this one right here, in which I change things up on you a little bit. You have to read the question, as Gianna tells us. Read the question. We calculated the probability of drawing a blue out of a box every time, a blue, a green, and a green. Not a blue, they all came up to 1/8, and then I asked you this, and it came up to be 7/8. This would be a great thing to look at when you're studying for your test. Okay, dependent events. Formula is different. Here it is. We're just going to stick with two events for now. Probability of event A and the probability of event B. Take your probability of event A multiplied by your probability of event B
After A.
Because remember, we threw the stick away, right?
Yes.
So does A really impact B now?
Yes.
Again, I encourage you, read through all of our examples here. We gave you the phrase math rules, you cut the letters up, threw them in a box, and we asked you what's the probability of drawing two consonants. You guys said, well, if you draw a consonant, there's 6 of them, there's 9 letters. But we're not replacing, are we?
No.
So now we're down one consonant, we're down one letter, we multiply them together, super duper, right? Then we did vowels. A little bit less of an opportunity, actually quite a bit less of an opportunity. There are 3 vowels, there are 9 consonants. We threw the vowel away once we drew it. We're down to 2 vowels and 8 letters total. There's your probability. C is where things got crazy on you a little bit. You had to answer the question again, as Gianna would say. What is the probability of drawing both consonants? What's the key word?
Or.
Both vowels. Yes, no? You've got to know the formulas and understand what the formulas are asking you, and you should be okay on this assignment. As long as you do, as Gianna said, answer what the question is asking you. Answer the question.